everyone. Welcome to Physics by Aaryan. I'm very happy to welcome you all in this today's lecture. So as you know, we have started a free foundation physics course. The purpose of this foundation physics course is to make sure that each and every student has a very strong basics. All the basics that you might need for your competitive exams has been covered in the 15-day long lecture series. Along with this lecture series, we also have notes for each topic, quiz for each topic, and so on. So if you really want to take a proper advantage of this course, please go to our website or an app. You can find the link in the description, and there you can actually see all the notes and quizzes as well, along with this video lectures. In first two lectures, what we covered is we covered basic graphs in physics. What are all the graphs that you might need and what are their applications in the physics. Now in the second lecture, I am now starting Dirac Delta Function. This is also a very important part of a physics because Dirac Delta Function is a very special function in physics and it is used at many places in physics. Now this is some sort of unusual function. You have to appreciate the beauty of this function because these kind of functions are usually not very common in the physics textbooks. This is a very special kind of function, but it is very useful in many branches of physics. So let's see what is Dirac Delta Function and what is this thing all about. So Dirac Delta Function is represented by a symbol known as delta symbol. So this symbol is known as delta symbol. So we represent Dirac Delta Function using this symbol. So Dirac Delta Function is written as delta x minus a. So where x is your function and a is your point. What does this mean? What does delta x minus a means? So the definition, by definition, the Dirac Delta Function is defined as if your x is a, then your delta x minus a will be infinity. So if I say what is delta x minus a, if I ask you what is delta x minus a, so you will say, okay, if x is equals to a, then it means your function will take up the value which is infinity. But otherwise, for all other values of x, your function will be 0. So let's try to see it through the graph. So we can see for all other values of x, your function is 0. You can clearly see this yellow line. Let me change the marker color so you can clearly actually see. So you can see very clearly for all other functions, for all other values of x, it is 0. But at x equals to a, the function is taking up x equals to a. Sorry, y equals to infinity. So when your x becomes a, your function goes to infinity. That is a number one definition of Dirac Delta Function. But this definition is incomplete. In order to completely define Dirac Delta Function, there is one more property. And that property is the graph which you are drawing. The area under that graph is 1. So whatever graph I'm showing you, the area under that graph is 1. How do you mathematically represent that? You know the area under graph is given by y dx. So this is your area under graph. What is your y here? Y is delta x minus a. And what is your dx? Dx is dx. So if you find this area, you should get an answer 1. So in order to completely define Dirac Delta Function, you need two definitions. Number one, that your Dirac Delta Function is infinity when x is equals to a. Now this a can be anything. A can be 1, 2, 3, minus 1, minus 2, minus 3, and so on. And second is the area of this graph is 1. It means delta x minus a dx integration gives you an answer of 1. So these two definitions makes a complete definition of Dirac Delta Function. So now let's move on. Let me just give you some brain teaser, or let's say a quick revision kind of thing. If I say what is delta x plus 2, how will you plot this? So I can write delta x plus 2 as delta x minus 2. It means how my graph will look like. My graph will be 0 everywhere, but at x equals to minus 2, my graph will be infinity. So this is my graph. This is my graph. So you can draw any Dirac Delta Function graph using this way. Okay, so I hope the definition of a Dirac delta function is clear. Now, another property, very significant property of Dirac delta function is this one. So if you say integration of fx is any function, multiply by Dirac delta function x minus x naught. So here nothing, I have just replaced a with x naught. Same thing, nothing is different here. So delta x minus x naught into dx will give you f of x naught. So now this might look out very general, or maybe many of you wouldn't have been able to understand, but I have written here. So let's try to easily understand this concept. So let's understand this with an example. So if I say solve this integration, so your integration limits are 0 to 2 pi. Okay, very good. Then your function is sin x. Okay, fx is sin x here. I got an idea. And delta x minus pi by 2. So what is your x naught, or what is your a? This is equals to pi by 2 in this case. So what I will do is, the answer of this integration will be, I will take my function which is sine, and I will put the value of a. So I will say my answer is sine pi by 2, and we all know that sine pi by 2 is 1. So this is how we find these kind of integrations. So whenever there is a function and then you multiply it with some Dirac delta function, so your answer is what? So you take the same function and put the value of a, or let's say x naught, whatever you want to call it. So you will say my answer is sine pi by 2. Very good. Let's understand with one more example. So your limits are again 0 to 2 pi, and now your function is cos x. And now your Dirac delta function is x minus pi. Very good. So now pi is a naught or x naught, whatever you want to call it. So what I will say answer is cos, and in my x I will put the value of a, which is pi. So cos pi is minus pi. Very nice. So this is how we solve the integrations. Now I just want to change something. Now I want to surprise your mind. So carefully see what I'm going to do now. Now I'm saying my function is cos x, but my Dirac delta function is x minus pi. Very good. So now why I have written 0 here? Why my answer is 0? What should be my answer? According to first two examples, what should be my answer? So you will say, okay, sir, your answer will be cos, and put a value of a, which is pi. So your answer should be minus 1. So why you wrote 0 and not minus 1? That is a genuine question. So here you carefully see that your pi, which is a, is outside the limits. Your pi is outside the limits. So your limits is 0 to pi by 2, but pi is outside the limit. So whenever your a is outside the limit, your answer is 0. But in the first two examples, you can clearly see, in first example, a was pi by 2, and it was inside the limits of 0 to 2 pi. In second case, your a was pi, and it was inside the limits of 0 to 2 pi. Similarly, you can see in this third case, your a is pi, but now your limits are from 0 to pi by 2. It means your pi is outside the limits. So you cannot put pi in your function. You cannot say your answer is cos pi. Instead, your answer is 0. So always remember, whenever your a value is outside the limits, your answer of this integration will be 0. But if your a value is inside the limits, then what you will do is you will put the value of a in your function. That is the rule of solving the integration quotients in the Dirac delta function. Very nice. So this is the analysis what I want to tell you. Now let's again do it. One more function, one more example. So now my function is x divided by x square plus 1, and my function, my Dirac delta function is delta x minus 1. So my a value is 1. Very good. So I will put my a value in my function. So let's put it. If we put the value, I will get 1 divided by 1 plus 1, which is half. Why I can do this? Because you can see 1 is inside the limits. My limits are from 0 to 2, and my 1 is within the limits. So I will put my 1 in my function, and I will get my answer as half. Now let's do the same problem, but this time I will change the limits. Now my limits are not from 0 to 2, but my limits are from minus 0.5 to 0.5. Now you can clearly see 1 is outside limit, out of the limit. So what will be your answer? 0. So whenever your a is outside the limit, your answer becomes 0. I hope this point is very clear to you, because many times these kind of questions are directly or indirectly asked in the competitive exams. Nowadays, even in IIT JAM also and CUET exam also, this Dirac Delta function is coming up. So this function is very important for BSc as well as MSc students. And it is even more important for MSc students. Okay, so now let's move to the properties of this Dirac Delta function. The number one property of Dirac Delta function is that it is an even function. Now, if you have never heard what is even and odd, let me give you a very rough idea or very quick idea that if your negative of function is equals to f of x itself, then it is even function. I don't want to bore you with the mathematics, but I want to really give you a feeling. So let's say my function is x square. So if I put x equals to minus x, I still get x square. So my value of f of minus x and my value for f of x is same. Either I put x, I will get same answer. Or if I put minus x, again, I will get the same answer. So the functions which gives the same answer for minus x as well as plus x are known as even functions. So Dirac Delta function is an even function. If you put minus x, it will give you the same answer if you put as plus x. So always remember this. Dirac Delta function is an even function. For example, delta of minus 2x equals to delta 2x, because you can simply ignore the negative sign. Very nice. If it is clear, let's move to the second property. Second property is delta of ax. Delta of ax is equals to 1 by modulus of a. So we covered modulus in last lecture. It makes everything positive into delta x. What do I mean by this? So let's take delta minus 3x. Now what I can do is, here my value of a is minus 3. So I can bring this minus 3 in the bottom and put it in a modulus. And I can just simply write delta x, whatever is remaining. So minus 3 mod is plus 3. So I will get 1 by 3 delta x. So this is how we simplify the Dirac Delta function. So we simplified delta minus 3x into 1 by 3 times delta x. So it is very important that in questions before you start solving, you simplify the Dirac Delta functions that are given to you. Okay, now let's move to the next part. The next part is delta gx. Now delta gx equals to summation of delta x minus xn divided by modulus of g dash xn. Oh my God, very tough equation. What is the meaning of this equation? I always like to look through the equations. I never enjoy by just looking at the equation. I really like to feel the equations. So let me give you a feeling. So now what is inside my delta function? Inside my delta function is another function. Oh my God. Inside my delta function, there is another function. Crazy. Let's take an example. So delta x square minus 1. Okay. So it means inside my delta function, the function which is there is x square minus 1. So it means my gx is x square minus 1. And what do I want to do? What is my purpose? I want to simplify this delta function. I want to reduce it to a simpler form which I know. So how do I do it? So whatever function is inside delta function, whatever is inside delta, find the roots of that function. So if you find the roots of x square minus 1, how do you find the roots? Just make function equal to 0 and find the values of x for which the function is satisfied. The equation is satisfied. So you know x square minus 1 equals to 0. It means x is equals to plus and minus 1. Very simple concept. So the roots of equation, roots of the function gx is x equals to plus minus 1. So this is my first step. First step is finding roots. Second step is find derivative. So whatever gx is given to you, just find the derivative of that. So if you find the derivative of x square minus 1, I hope you all know the differentiation, you will get 2x. Now you are all ready. Now let's look at the formula. So your formula is delta gx equals to summation delta x minus xn. Here, what are xn? Roots. And xn are my roots. So what are my xn? So my xn are plus and minus 1. So first I will write as delta x minus my first root. What is my first root? 1 divided by g dash times value of 1. So whatever my g dash value is, I will put my root in that. So I will put my root value in g dash x. Now again, I will do x minus, what is my second root? Minus 1. And I will put my root into my g dash x. So this is what you will get. Again, I want to repeat this because this is a very tricky concept. So I found the two roots, one is 1 and one is minus 1. So on numerator, what I will write is delta x minus my root, delta x minus my second root. And what will I divide with? G dash of value of my root, g dash of value of my other root. And I will take the modulus in the denominator. So if you see, if I put 1 in my g dash x, if I put 1 in my g dash x, I will get 2. And I need to take a mod of 2. Mod of 2 is simply 2. Now, second term. So this minus minus will become plus. You can clearly see this minus minus will become plus here. And I will divide with, now I need to put minus 1 in my g dash. So if I put minus 1 in my g dash, I will get minus 2. Simple. And minus 2 mod will also be plus 2. So what is my answer then? So I will get delta x minus 1 divided by 2 plus delta x plus 1 divided by 2. So what do I got? I can take 2 common and I will get 1 by 2 delta x minus 1 and delta x plus 1. So this is a simple function which I know. I can even plot this function. Very easy. So your function will be 0 everywhere except at x equals to 1 and at x equals to minus 1 because there are not two delta functions, right? So this is your function. This is the plot of your function. I hope that you have understood this concept, that how do we use this property? This property is to reduce the complex delta functions. Whenever there is a function inside a delta function, you use this property to reduce it. Now let's move on. Let's do one more example so that we are very clear. Again, you can see inside delta, there is a function. What is the function? Function is x minus a into x minus b. So what are the roots? So you will say, okay, to find roots, I will make x minus a and x minus b equals to 0. And what are your roots? Your roots are either a or b. So you got two roots, a and b. So your roots are a and b. Now what is the next step? You take a derivative. So if you derivate this function, what you will get? You will get 2x minus a minus b. Absolutely correct. Now what you will do? I will put a in my g dash a. So if I put a in my g dash a, I will get a minus b. Then I will put b in my g dash. Then I will get minus of a minus b. Very nice. So now I can simplify my function. So in numerator, what do I write? Delta x minus my first root plus delta x minus my second root. And how do I divide it with? I will divide with a minus b mod and minus of minus a minus b mod. So both of this will give me delta x minus a mod of a minus b plus delta x minus b mod of a minus b. So this is my final answer. So you can solve any of such question using this property. So this property is a very powerful tool. And many times, if you will see, the direct questions have been asked in GATE and CSIR net based on these properties. Okay, I hope that you have understood till here. I will sincerely recommend you all to read the printed notes which I have given. If you're watching this lecture only on YouTube, then I would say go to PhysicsByAaryan.com, www.physicsbyaryan.com, or download the app and then open up any course. Whatever preparation you are doing, let's say you're preparing for CSIR, just go to that course and see the free preview. You will find all the notes and all the quizzes there. The notes have many examples, so you can practice even more examples so that you really understand the concept. If you have any more doubts, let's say you have not understood anything, then I'm taking doubt class on next Sunday. So you can join that doubt class and ask as many doubts as you have or you can even ask the doubts in Telegram channel or in the comment section. Okay, I will be happy to answer that. Now let's move to the next part, derivative of delta function. So how will you take the derivative of a delta function? That is a question that you might ask. So first of all, I want to mention one thing. I want to clarify one thing. It is very difficult to say what is the actual value of delta dash x. What is this delta dash? Dash means derivating one time. If you derivate any function one time, you put dash. If you derivate any function two times, you put two dash. So I can write dy by dx as y dash, and I can write d square y by dx square as y double dash. So this thing you might know. Okay. So it is very, very hard to say what will be the value of delta dash x or delta double dash x. But there are some properties which are useful in this talk. So I want to give you some properties of a derivative of a delta function. So let me give you some properties. Number one property which I want to mention is again very big kind of equations. So here delta m dash x means derivating the function m times. So what is delta m means? You derivating the function m times. This is equals to delta mx. Okay. Multiply by some function fx. This will be equals to minus m1 raised to power m. So here will be m raised to power into 0. So you put a value of 0. So don't get worried with the equation. I will explain you what does it this equation is telling. So let's understand with an example which I always enjoy rather than talking about the general formulas as such. So you see here delta double x. It means the value of your m is 2. So you are derivating your delta function 2 times. And your fx is x square plus 1. So your fx is x square plus 1. Very nice. And 2 dx. So what it is equals to? Minus 1 raised to power m. So minus 1 raised to power m. So m is 2. So I will raise it to the power of 2. And then I will derivate the function m times. Whatever function is given to me, I will take the derivative m times. What is m here? 2. So I will take the derivative of x square plus 1 2 times. So if you derivate x square plus 1 2 times, so if you derivate it one time, you will get 2x. And if you derivate it one more time, you will get 2. So I will write 2 here. And then I will put the value in this function as x equals to 0. So if you put x equals to 0 in 2, you still get 2. There is no change. Whatever value you put in 2, you get 2 because there is no x in the function. Okay. So 2 is 2 for all values of x. 1 is 1 for all values of x. So what is your final answer? Minus 1 whole square into 2 is only 2. That is what I want to tell you. Now let's understand with one more example. Now you are doing, let me rub this. So you are doing delta dash x. So your m value is 1 because you are only derivating it one time. And your fx is still x square plus 1. So what is your answer then? Minus 1 raised to power m. So minus 1 raised to power 1 because now your m is 1. Then you derivate your fx how many times? M times. So what is m here? 1. So you will derivate your function one time. So let's derivate your function one time, 2. It will give you 2x. Now in this 2x, you will put a value x equals to 0. So now let's put value x equals to 0. You will get 0. So this is how you solve this kind of problems. So instead of delta x, if some derivative is given to you, you solve it like this. But instead of delta, in that double derivative, only delta would have been given. Let's say this equation was like this. Simple. Then I already discussed that how you solve it. How you solve it? You put a value of 0 in your function and you get an answer. But if your a is outside the limit, your answer is 0. So this was the first thing we discussed. But now instead of delta x, what is there? Its derivatives. So then I also gave you a formula that if instead of delta function derivatives are there, how do you solve the problem? I hope that you have understood this concept. So let me rub this so it looks more clean. Now let's move to the next part of the topic. Second property of derivative of Dirac Delta function. Now I already told you that okay, Dirac Delta function is even. But what about its derivative? So if it is derivative is given by like this, so delta mx equals to minus 1 raised per m delta m of minus x. What does it mean? Very, very tricky general equations. Let's understand with example. So if it is delta 3x, means you are deriving it 3 times. Then minus 1 raised to 3 as such, and then delta again 3 powers, and instead of x we are getting minus x. So your delta triple x equals to minus of delta minus x. It means this is an odd function. Odd means you are not getting the same answer for x and minus x. Instead, you are getting a negative sign with it. So again, I want to repeat. If you get like this, your answer will be minus of delta x. If you have double derivative of your function, then your answer is this. If you have triple derivative, your answer is again minus of delta x. You can verify this, because in this example I will raise minus 1 raised to power m, so you will get a minus sign. In this I will get minus 1 raised to power 2, so I will not get a minus sign. In this again I will say minus 1 raised to power cube, again I will get minus sign. So you can clearly see first derivative is odd, second derivative is even, third derivative is again odd. This process will keep on repeating itself. So if someone asks you that is this odd or even, it's seventh derivative. So you will say since m is odd, so this is also odd, because minus 1 raised to power 7 will be minus 1. So you can clearly tell which derivative will be odd or which derivative will be even. For example, delta 4x. Is this odd or even? This is even, because minus 1 raised to power 4 is 1. It means it is even. So you can clearly tell that which of this is an odd and which of this is even. Nice. So this is what I'm trying to tell you. Odd means the value of x and minus x is not same. The value of function at x and at minus x, it is not same, but there is a negative sign between them. But what is odd? Odd means the value of x, value of y at x and minus x is same. So whatever is the value at 3, the same value is at minus 3. Okay, so this is the meaning of even and odd. So let's move to next part. This was the property number 2. This helps us to tell us, this tells us which of the derivative is odd and which of the derivative is even. Okay, the third property. Third property is x raised to power m plus n, m plus 1 into delta m gives you 0. So if you have x cube into delta double dash x, you can clearly see here, you can write like this. So this will give you 0. So if here m is 2. So if you have double derivative, and it is multiplying with the x which has one more power. So if you are double derivating your function and you multiply it with the x cube, you will get 0 answer. Similarly here, you can see you are derivating your delta function 1 times, but you are multiplying it with the x 1 power more. That is x square. So you will get an answer of 0. So this property is also very important, because many times in physics, what happens is we have x some power and multiply by delta some derivative. So you can directly use this situation. Always remember, this is not a power of delta. This represents derivation, differentiation. How many times you are differentiating your delta function? If m is 2, it means you are differentiating your function 2 times. If m is 3, it means you are differentiating your delta function 3 times. But here m is power, that you are raising your x to some power. If here m is 2, it means you have x cube. If here m is 1, it means you have x power 2. So this is the separate meaning of m in both the terms. Okay, so always remember this. Okay, so let's solve some example. So here you can clearly see I am asked that you want please solve this equation for me. How will you solve this equation? So as we already use this equation, that if the first property I gave you, right? Delta mx into fx will give you minus of m fm0. So we will use the same property here. So what is your fx here? Fx is x. What is your m here? M is 1 because you are differentiating in 1 times. So what will be your value here? I think it will be minus sign. Sorry for that. So you will raise your -1 to 1 and you will put the value of 0 to your f dash x. Okay. So that is what I told you already, that if you have fx times delta dash x, what you will actually do here is you will first take a derivative of your f dash x and then put a value of 0 in this. That is simply what we did in last time also. So let's do it. So now your fx is, sorry, here -1 will be there. So what is your fx is? Fx is x and you are derivating in 1 times. So you will first take a derivative of your function, which is 1, and then you put a value of 0 in 1. So if you put 0 in 1, it will remain 1 itself. Whatever you put in, whatever is a value of x, your 1 remains 1. So the answer of x delta dash x dx is 1. You can practice more such examples in my notes given to you, because in the very beginning, sometimes what happens is Dirac delta function seems that what is going on, because there is no physics to see here. It's a pure mathematics. So you can actually solve many examples and then you will actually get a feeling that, okay, this is how to apply the formula. The only thing that you should know here is how to apply the formula. And once you know all the examples which I am discussing here are most important, because only these functions or these properties are used in actual physics, or they have been asked in GATE or NET only from these properties. Okay, next, I want to mention that what is Dirac delta function in spherical and polar coordinates. So spherical and cylindrical polar coordinates. So if cylindrical coordinates are there, you know cylindrical coordinates are described in 3 terms: r, theta, and z. If you don't know, my next lecture is on cylindrical coordinate itself. Don't worry, if you don't know what is cylindrical coordinate system or what is spherical coordinate system, the next lecture which is going to come is on cylindrical and spherical. If you do delta cube r minus r naught, so now I will not say x minus x naught, because it's a 3D function. Cylinder is a 3D body. So I will not say it is x minus x naught. So what is this 3 means? It means it is a 3D Dirac delta function. Initially, I was only writing delta x minus x naught because it was 1-dimensional delta function. Now it is 3-dimensional delta function. That is why the 3 has been written there. So how do you write in cylindrical coordinates? So you write 1 by r delta r minus r naught, theta minus theta naught, and delta z minus z naught. Similarly, in spherical coordinates, you define your spherical coordinates by r, theta, and phi. So your delta, sorry, here cube will also be there. Delta cube r minus r naught will be 1 by r square sine theta into delta r minus r naught, delta theta minus theta naught, and delta phi minus phi. This r and r square sine theta is a very special thing. I will discuss this in my spherical coordinate system lecture, that why only 1 by r square sine theta is multiplied. Why there is nothing and anything else is multiplied. Why only r square sine theta? So I will discuss this in my spherical and cylindrical polar coordinate system, that why only r square sine theta. Okay, last is Cartesian. So let's say you have a 3D function. Now not only x, you have y and z also. So what you will write? You will say delta x minus x naught, delta y minus y naught, and delta z minus z. You don't have to multiply anything here. You can think it is being multiplied with 1. So nothing is, in a way, nothing is multiplied here. So simply in 3-dimensional Cartesian coordinates, you write delta r minus r naught as delta x minus x naught, y minus y naught, and delta z minus z naught. So many times in exam, it has been asked that what is Dirac delta function in spherical coordinates, or what is Dirac delta function in cylindrical coordinates. So you should remember these formula. They have came directly. Okay, so now I want to solve one problem in front of you. Okay, so let me rub this and I will solve this problem live. So slowly you can see each and every step and you do not get confused. So I will rub this and I will solve this problem in front of you only, so that you can actually see that how I am solving it. So here you can clearly see you get a delta function, and inside delta function there is one other function, gx, and then it is being multiplied with some function which is fx. Okay, so inside delta function I got another function which is gx. So what is my gx? Gx is x square minus pi square. So whenever there is gx inside delta function, what I do, I reduce, I simplify my delta, reduce delta. So how do you reduce delta? Number one steps, find the roots of gx. So the roots of gx will be x equals to plus minus pi. That is my step number one. What is my step number two? Find g dash x. If I find g dash x, I will get 2 pi, 2x. Now put the value of your roots. So if I put x equals to plus pi, I will get 2 pi. And if I put x equals to minus pi, I will get minus 2 pi. Very nice. Then how I can write my delta x square minus pi square? Very simple. I will write delta x minus pi divided by mod of 2 pi plus delta x plus pi divided by mod of minus 2 pi. So what I will get? I will get 1 by 2 pi delta x minus pi plus delta x plus pi. This is what I will get. So I have now reduced my delta function because these are the simple functions. I know how to deal with these ones. Now let's go back to question. So I reduce this thing. Now I will again put the value here so you can see. So your limits are from minus infinity to infinity. Okay. And you will say minus 1 by 2 pi delta x minus pi plus delta x plus pi multiply by cos x into dx. Okay, very nice. Very nice. So I can open this thing up. So I can open this bracket so that x minus pi is multiplied by this also and this also. So cos x is multiplied with both the terms. So first integral that you will get is this one, and the second integral that you will get is this one. So how do we solve this now? Remember first property. Remember first property. Fx delta x minus a dx. What I do is I simply put the value of my a in my function and I get f of a. This was my first property. So now what is my a? Pi. So I will put x as pi and here I will put x as minus pi. So if I put cos pi and here I will get cos minus pi, and outside there is 1 by 2 pi being divided, which is coming from here. So 1 by 2 pi is already there. So I divided by, so I get cos pi plus cos of minus pi. Both of these are minus 1. Cos pi is also minus 1 and cos minus pi is also minus 1. So I get an answer of minus 1 by pi. So this is my answer. So as you can clearly see, I used two properties here. Number one, to reduce my delta function, and number two, to solve the integration. So this is some sort of advanced level problem that might come in GATE and NET, and even for JAM students or TIFR and JEST students, this is very important. In JAM, maybe the question do not come from this part, but in TIFR and JEST, definitely the Dirac delta function is coming very, very much in a good amount. Okay, now let's move to next part. Last thing which I want to discuss before I end this session, I just want to give you one application of Dirac delta function in physics. So many of you might have heard about wave function. That wave function, we define a wave function for each particle, or let's say for each quantum body. what is a wave function of a particle which is sitting at x equals to a? So if I ask you that, okay, tell me what is a wave function of a particle who is sitting at x equals to a? So you will say your wave function of particle who is sitting at x equals to a is delta x minus a. Always remember this. In many interviews, this has been asked to me. That what is a wave function of a particle sitting at a? Why this can be a wave function? Whenever you want to verify, so you can clearly see your particle is sitting at x equals to a. So at all other places, your position, your particle is not there. It means it is 0. Probability to find a particle at any other place is 0. Okay, but at a it is infinite because your particle is there only. And how do you define your probability? By integration. So if you integrate delta x minus a, you know you are going to get an answer of 1 because area under graph is 1. So probability has to be 1. So how do you find the probability? By doing the integration of your wave function. You take the square of your wave function and then do an integration. And you know the area of the graph is going to come 1. And probability also needs to be 1 because probability of finding particle at A is 1 because it is at 1. Sorry, let me repeat. Probability of finding a particle at A is 1 because it is sitting at A itself. And probability of finding particle at any other place is 0. So this is what exactly Dirac delta function is. It is 0 everywhere else, but it is infinity at A. And if you take its integration, you will get an area equals to 1 and area is equals to probability. If you will study quantum mechanics more in detail, then you will understand what I am telling in depth. But for now, you should remember that the wave function of a particle sitting at x equals to a is Dirac delta function. So you clearly see that we actually see Dirac delta function in actual physics. It is not just mathematical something. In EMT also you will see Dirac delta function at many places. So when that topic will come, I will again bring this Dirac delta function back. In my entire course, I will be bringing this function back and back. So this lecture is very important. Read the notes of this lecture and then you can go forward. Okay, so see you all in the next class. In next class, I will be discussing spherical and cylindrical polar coordinate system. So goodbye.